this episode, we're going to tackle a topic that often gets ignored until it causes trouble: retention and deletion. When people are new to cybersecurity, they sometimes assume risk comes mainly from what is happening right now, like a live attack or a current system misconfiguration. In reality, long-term exposure is one of the biggest sources of harm, because the longer sensitive data sits around, the more opportunities exist for it to be accessed, copied, leaked, or misused. AI systems expand this exposure problem because they can generate and store new kinds of data artifacts, including prompt histories, output transcripts, training datasets, test datasets, and logs that capture interactions. Retention is the decision about how long you keep each category of data, and deletion is the disciplined act of removing it when it is no longer needed or no longer allowed. The AI Security Manager, AAISM, mindset is to treat retention and deletion as a proactive risk reduction strategy, not as a cleanup chore. By the end, you should understand why retention and deletion are central to AI data risk, how to design retention rules that are defensible, and how to manage deletion so it actually reduces exposure. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to start is to understand what retention really means in practice, because it is easy to confuse retention with storage. Retention is not simply where data is stored. It is the intentional decision that data will exist for a defined time period for a defined purpose. That purpose might be model training, quality improvement, incident investigation, compliance evidence, or operational troubleshooting. When data is retained without a purpose, it becomes pure risk because it creates exposure without providing value. Deletion is the opposite decision, meaning the data should no longer exist because its purpose is complete or because keeping it would violate obligations or increase risk unnecessarily. Beginners often assume deletion happens automatically, but in many systems it does not unless someone designs and enforces a process. Another important concept is that retention applies to many forms of data, including backups and derived datasets. And if you delete only one copy, but leave many other copies, exposure remains. Retention and deletion therefore require a life cycle mindset where data is tracked, controlled, and removed intentionally. When you treat retention as a purposeful commitment and deletion as a controlled process, you can see why this topic matters for long-term AI safety. AI programs create retention risk because they generate more data than many traditional systems, and they often spread that data across multiple tools and repositories. Training datasets may be assembled from multiple sources and stored in multiple versions. Test datasets and evaluation results may be stored for repeatability and comparison. Prompts and outputs may be logged for monitoring or debugging, especially in systems that support many users. Vendor services may retain interaction data depending on configuration and service terms, and those retention behaviors can be easy to forget. Beginners should recognize that retention risk is not only about massive datasets, because even small prompt logs can contain sensitive details that create major exposure if accessed improperly. Another risk is that as time passes, organizations lose context, meaning they forget why data was kept and who is responsible for it. That loss of context turns retention into unmanaged accumulation, which is a classic security failure pattern. Retention and deletion controls restore context by forcing teams to define purpose, ownership, and duration for each data category. Without those controls, AI data exposure grows quietly until an audit, incident, or contract review reveals the problem. A disciplined retention strategy begins with classification and categorization, because you cannot assign retention rules if you treat all data as one bucket. Different categories have different risk and different value. Training data may need to be retained for a period to support reproducibility and to investigate model behavior, but it also may contain sensitive information that should not be kept longer than necessary. Test data may need retention for repeatable evaluation, but it can also be sensitive and may require stricter handling. Prompts and outputs may be valuable for debugging and monitoring, but they can also contain sensitive information that creates unnecessary exposure if kept indefinitely. Logs may be required for security monitoring and investigations, but logs can become sensitive repositories in their own right. Derived datasets, such as cleaned or labeled versions, may carry the same sensitivity as the source and should inherit similar retention rules. Beginners should understand that categorization is not just administrative. It is how you assign realistic retention and deletion expectations. When categories are clear, you can match retention duration to purpose and risk. This is the foundation for a defensible retention program. Once categories are defined, the next step is defining retention principles that keep decisions consistent across teams. A key principle is purpose limitation, meaning data should be kept only as long as it serves a legitimate, defined purpose that aligns with obligations and business needs. Another principle is minimization, meaning retain the minimum amount of data needed to achieve the purpose, because more data means more exposure. Another principle is risk-based duration, meaning higher sensitivity data should generally have shorter retention unless there is a strong justification. Another principle is traceability, meaning retention rules should be documented so the organization can prove why data is kept and for how long. Beginners sometimes assume longer retention is always better for analysis, but in security, long retention without strong controls increases breach impact and compliance risk. Retention decisions also must consider the reality that people forget and systems change, so the longer data is kept, the harder it becomes to maintain correct access boundaries and context. When retention principles are explicit, teams make consistent decisions rather than defaulting to keep everything forever. Retention rules become practical when they are written as testable requirements tied to ownership, because ownership is what makes rules enforceable. Each data category should have an owner responsible for ensuring retention and deletion rules are applied, reviewed, and adjusted when needed. For example, a dataset owner might be responsible for ensuring training data is not retained beyond the approved period and that derived datasets follow the same rules. A system owner might be responsible for ensuring prompt and output logs are retained only as long as needed for monitoring and that sensitive content is not stored unnecessarily. Beginners should understand that if ownership is unclear, retention rules become suggestions and data accumulation becomes the default. Ownership also supports evidence because you can show who is accountable for compliance with retention rules. Another important aspect is defining review cadence, meaning retention rules are checked periodically to confirm they still match reality and obligations. When ownership and review are built in, retention becomes a living control rather than a forgotten document. This is how you prevent long-term exposure from creeping back in after initial cleanup. A major challenge in AI systems is that prompts and outputs create a new category of data exposure that many organizations do not manage well. Prompts often include copied content, and outputs often include summaries or interpretations that may contain sensitive details. If prompts and outputs are stored indefinitely, they become an unbounded sensitive dataset created by normal user behavior. Beginners should recognize that even if the system was not intended to store sensitive information, users may include it anyway, which means retention rules must assume sensitive content can appear. A defensible approach includes limiting how long prompt and output histories are retained, restricting access to those histories, and ensuring they are not used for training or improvement unless explicitly allowed and controlled. It also includes clear acceptable use guidance that reduces the amount of sensitive content users put into prompts in the first place. Another important point is that output storage locations, such as tickets, documents, or chat logs, may have their own retention rules that need alignment. If outputs are copied into long-term repositories, deleting the original system logs may not reduce exposure. Prompt and output retention must therefore be coordinated across systems to be effective. Training and test datasets also create long-term exposure risk because they are often copied, versioned, and shared among teams for experimentation. A retention strategy should address dataset versions explicitly because old versions can linger and remain accessible even after the main dataset is updated or deleted. Beginners should understand that version history can be valuable for reproducibility, but it also expands exposure, so retention must balance those needs. A practical approach is to define which versions must be retained and why, and to delete versions that no longer serve a defensible purpose. Another important concept is handling derived datasets, such as labeled or transformed versions, because those can be forgotten and left in insecure locations. Retention should also consider test data integrity, because keeping outdated test data can lead to misleading evaluation and unsafe decisions. If test data no longer reflects the environment, it may create false confidence, and retaining it does not serve a useful purpose. When dataset retention is managed intentionally, the organization reduces long-term exposure while preserving what is truly needed for accountability and quality. Deletion is the part that turns retention from a plan into actual risk reduction, and deletion has its own set of challenges that beginners should understand. Deletion must be complete enough to reduce exposure, meaning it should address primary storage, derived copies, and backups according to defined rules. It must also be verifiable, meaning the organization can show that deletion occurred, because promises of deletion without evidence are not defensible. Another important aspect is timing, because deletion should happen on schedule rather than being postponed indefinitely, and postponement is common when deletion processes are manual. A mature program therefore designs deletion workflows that are predictable and tied to triggers, such as project completion, model retirement, or expiration of a retention period. Beginners should recognize that deletion is not always immediate wiping, because some systems use archive states or backup retention that must be managed carefully, but the core requirement remains that data is removed from accessible systems when no longer needed. Deletion must also respect legal holds, meaning sometimes data must be retained due to litigation or investigation, and those exceptions must be documented and controlled. When deletion is disciplined, it shrinks the organization's long-term attack surface and reduces the impact of potential breaches. Secure deletion also requires thinking about access paths and indexing, because data can remain discoverable even when a main copy is deleted. For example, a deleted document might still exist in cached copies, search indexes, logs, or export archives. Beginners do not need to know technical wiping methods, but they should understand the governance concept that deletion must include all relevant repositories and references. This is why inventory and data mapping are prerequisites for effective deletion, because you cannot delete what you do not know exists. A mature program uses the inventory to identify where data categories are stored and how they propagate, then designs deletion processes to cover those paths. Another important idea is that deletion should be tied to access reduction as well, because even when data is retained for legitimate reasons, access should be narrowed over time to reduce exposure. For example, older datasets retained for audit purposes may require stricter access controls than actively used datasets. Deletion and access reduction work together because both reduce long-term exposure. When you think about deletion as part of an end-to-end exposure reduction strategy, it becomes a clear risk management practice rather than a technical detail. Third-party services add complexity to retention and deletion because the organization may not control the full data lifecycle, but obligations still apply. If prompts, outputs, or training data are sent to vendor services, the organization must understand vendor retention behavior, configuration options, and contractual commitments related to deletion. Beginners should understand that a vendor service might retain interaction data for troubleshooting or improvement unless configured otherwise, and that retention behavior can change with service updates. A defensible program includes due diligence to understand retention and deletion terms, contract clauses that define expectations, and processes to verify that data is handled as agreed. It also includes limiting what data is sent to external services, because the safest third-party retention risk is the risk you never create. Another important point is that deletion requests to vendors may require formal processes and may not be immediate, so governance must plan accordingly. Retention and deletion in third-party contexts therefore become a combination of technical configuration, contract management, and evidence collection. When third-party retention is managed explicitly, the organization reduces surprises and strengthens defensibility. Retention and deletion also intersect with monitoring and incident response, because logs and records are often essential for detecting and investigating problems. Beginners sometimes hear delete data and assume the organization should delete everything quickly, but that can undermine security if it prevents investigation and detection. The goal is balance. Keep what is necessary for security operations and compliance evidence, but do not keep more than necessary or keep it longer than justified. This is where purpose-based retention becomes important, because monitoring data should be retained long enough to support detection trends and investigations, but not indefinitely without reason. Retention rules should also define what data is captured in logs to begin with, because capturing highly sensitive content in logs increases exposure and may not be necessary. In AI systems, prompts and outputs may appear in logs, so logging policies should consider redaction and minimization where appropriate. Another important point is that during an incident, retention rules might need temporary adjustment under controlled authority, such as preserving evidence for investigation, and those exceptions must be documented. When retention and security operations are coordinated, the organization can both reduce long-term exposure and maintain the ability to respond responsibly. Keeping retention and deletion effective over time requires routine governance checks, because this area drifts just like inventory does. Data accumulates, new logs are created, new datasets are copied, and new systems appear, and without periodic verification, retention rules become aspirational. A mature program includes periodic reviews that confirm retention schedules are being followed, that deletion processes are working, and that exceptions are controlled and time-bound. Beginners should understand that reviewing retention is not just compliance work, it is attack surface reduction, because every deleted dataset is one less target and one less risk. Reviews should also check alignment between systems, such as whether prompt logs are retained longer than policy allows or whether outputs copied into other repositories create unexpected long-term storage. Another useful practice is to measure data volume trends, because rapid growth can signal retention failure or uncontrolled copying. When governance checks are routine, retention and deletion remain real controls instead of written ideals. This continuous maintenance is what keeps AI data exposure from creeping back in. As we wrap up, managing retention and deletion is one of the most effective ways to reduce long-term AI data exposure because it shrinks the amount of sensitive material available for leakage, misuse, and breach impact. Retention is the intentional decision to keep data for a defined purpose and duration, and deletion is the controlled process of removing data when that purpose is complete or obligations require it. A mature program categorizes AI data assets, defines purpose-based retention principles, assigns ownership, and writes retention rules that are testable and reviewed regularly. It pays special attention to prompts, outputs, and logs because those artifacts can quietly accumulate sensitive content, and it manages dataset versions and derived copies to prevent hidden exposure. Deletion must be verifiable and comprehensive enough to cover key repositories and propagation paths, and it must coordinate with monitoring and incident response so security capability is not undermined. Third-party services add retention complexity that must be managed through configuration, contracts, and evidence. Finally, routine governance checks keep the program honest as systems evolve. For a new learner, the key insight is that reducing exposure over time is not glamorous, but it is one of the strongest, most defensible ways to make AI use safer and more sustainable.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.